Today's topic is magic tea, that is EH plane T junction. We can call it as EH, that is electric field and a magnetic field. EH plane junction T. It is also called as a hybrid junction. Or hybrid junction. Here, the combination of E plane T and the combination of H plane T. You already know the properties of E plane T and as well as H plane T. For your understanding purpose, I am repeating again. E plane or H plane T have three ports, namely 1, 2 and 3. 1 and 2 ports. It is called main waveguide, or we can also call it as port 1 and port 2 called as collinear arms or coplanar arms. When you go for port 3, it is H arm, or we can also call it as side arm. H arm or side arm. It is port 4. It is E arm. It is E arm. It is also we can call as a side arm. Okay, these are the things. Just remember it. Port 1 and port 2 are called as collinear arms or coplanar arms, and it is the main waveguide. And another waveguide is introduced here. It is the H arm. It is also perpendicular to port 1 and port 2, and here also the same thing. Okay, it is the E arm. It is also perpendicular for both the port 1 and port 2. It is externally we are introducing another waveguide. This is the thing. And when you go for H arm, okay, HT, okay, HT junction, H plane T junction. Here you already know the working. For your just recalling your memory, that if we fed electromagnetic wave at port 3, okay, for H plane, if you fed electromagnetic wave at port 3, what happens means the electromagnetic energy equally divided, okay, equally divided for port 1 and port 2. It is the thing. Or if we fed input, okay, if we fed electromagnetic energy from port 1 and as well as a port 2. We are taking both port 1 and port 2 as inputs. Okay, we are taking port 3 as output. At the time we get the summation of these two signals, that is addition of these two signals. Okay, we can get at port 3. This is the function of HT. When you go for E T junction, for example, here we know that how the HT will works about that, and now we discuss about E plane T. Here when you go for E plane T, that is port 1, port 2 and port 4. Port 4 is the E arm, port 1, 2 are nothing but coplanar arms. Here if we fed a microwave energy at port 4, that is we are taking the port 4 as input, at that time the microwave energy is equally divided for port 1 and port 2. But small change, that is the microwave energy at port 1 and port 2 is equal, but it is out of phase. At port 2 we are getting out of phase, that is 180 degrees phase shift. This is the change, only change. This is not observed in H plane T junction. Only in the E plane T junction we observed this. Okay, next, if we are taking port 1 and port 2 as inputs and port 4 as the output, at that time the microwave energy, okay, if we fed microwave energy at port 1, it directly flow towards port 4, and if we fed the same microwave energy at port 2 also, why it means because we are taking port 1 and port 2 as inputs. So what is the output at port 4 means, here port 2 we get 180 degrees phase shift, and port 1 it is the same energy. Okay, here there is no topic of phase shift. So for example, if we fed this type of signal at port 1, okay, if we fed the same signal at port 2, okay, port 2, due to the port 2 the signal got 180 degrees phase shift. That means the addition of these two signals, it is a phase, okay, the phase difference is 180 degrees, right? So the addition of these two signals gives rise to 0. Okay, that is output at port 4 is 0. The both signal get cancelled. This is the operation of E plane T. In the previous class we already discussed about E plane T and as well as a H plane T. Here it is the hybrid junction, and we can also, it is called as a magic T. Why we are calling it as magic T and hybrid junction, we will discuss now. Here you know the operation of these. Okay, now we discuss about magic T. Here we have port 1, port 2, 3 and 4. If you take input as port 3, okay, only we are taking port 3 as input. Next, at that time, we get output at port 1 and port 2. Okay? Okay. The energy is divided equally for port 1 and port 2. At port 4, we get 0 output. Okay? We get only output at port 2 and port 1. We get 0 output. Okay, at port 4, that is E arm. Similarly, if you take port 4 as an input, okay, nothing but E arm, then the microwave energy will be divided equally, but for port 1 and port 2. But port 2, at port 2 we get 180 degrees phase shift. Okay, we get output. Here we get the same phase, there is no change, but energy is divided equally for port 1 and port 2. At port 3, the output is 0. Okay, now you understood about this. Similarly, if you take port 1 and port 2 as inputs and port 3 and port 4 as output, okay, port 3 and as well as port 4 as outputs, okay, then now here what is the energy we are giving? Okay, we get equally. Okay, at port 3 we get addition of signal. Okay, addition of port 1 and port 2 signal. At port 4, okay, at port 4 the signal get cancelled because it is a 180 degrees phase shift. Due to this, the signal get cancelled. At port 4 output is 0. Output is 0. This is the operation. Example, port 1 and port 4. Port 1 and port 4 is shorted with a matched termination. Okay, that means we are closing the two ports. Okay, we are closing the two ports. Only port 3 and port 4 is there. Okay, if you are propagating a microwave energy here at port 3, okay, so if you take input as a port 3 and port 1 and port 2 is terminated, okay, shorted, terminated. So at port 4 the output is 0. Why? It means because port 3 and port 4 is perfectly isolated, so there is no energy arrive at port 4. Similarly, if we fed any signal at port 4, it does not arrive at port 3. Okay, so what is the energy means? Here the energy does not arrive at port 1 and port 2 due to the matched termination. Due to the matched termination, the output energy is 0 at port 1 and port 2. So similarly, if we transmit a signal from port 4, okay, 1 and 2 is matched termination, then at port 3 is also 0. If you take the input, if you fed input signal here and it is a perfectly matched termination, at that time there is no signal. Okay, there is 0 signal will be arrived at port 3. So here you observe that two terminals, if two terminals is shorted, the remaining terminals is also perfectly isolated. Okay, so it is called magic tee. Okay, why you are calling it as a magic tee means if the two ports terminated, the remaining ports is also will be isolated. So there is no output you can observe at port 4 or port 3. This is the working principle. According to this, you have to write the equations. For H plane T, for H plane T, we can write as yes 1 3 is equals to yes 2 3. For H plane T, we can write as 1 3 is equals to 2 3. For E plane T, we know that it is out of phase, right? Port 2 is out of phase. So we can write as S 1 4 is equals to minus S 2 4. You have to remember this. Okay. Based upon the functioning, we are writing this scattering parameters. Okay. This is the thing. And here this is the thing. And after completing this, what we have to do means similarly, first we have to take the properties for a HT, and what we do according to the symmetric property, we are writing S12 is equals to S21, S131 is equals to S13. Similarly, we are preparing a matrix for this, and after that we are invoking a unitary matrix, that is S into S conjugation is equals to I, identity matrix. Okay, through this we get S parameters. Okay, and then substitute in B is equals to S into A. S is the scattering matrix, A is the inputs, B is the outputs, and we have to check the cases, case 1 and case 2. Okay, A and A2 is 0, that is we are taking at output here, and A3 as input here. Okay, like this we will see. Okay, we will see by using here. This is the three-dimensional view of a magic. Here we have 4 ports, so the scattering matrix is also 4 into 4 matrix, S11, S12, S13 like this up to S44. For H plane T, we know that S13 is equals to S23, S14 is equals to S24. Okay, just we discussed it here. Okay, just now we discussed these 2 points. So for this purpose you have to write it, and we have to write another thing for here. Yes 3 3 is equal to 0. Okay, and as well as yes 3 to 4 is also equal to 0. We know that if you fed any input at port 3, port 4 is 0. Similarly here also yes 4 4 is equals to 0. Okay, because E plane is perfectly matched, and here H arm is also perfectly matched, so we are taking S33 is equals to 0. Here E arm, okay, E arm is perfectly matched, so S44 is equals to 0. And next we know that the energy from 4 to 3 is also 0. Okay, substitute these all values in 4 into 4 matrix. Okay, scattering matrix. We know that a scattering matrix is S11, S12, S13, S14, and okay, like this. Next S21, sorry, S13 and S14. Similarly, up to S41 up to S44. That is 4 into 4 matrix. Substitute all these values here. Along with this, we know that you go for symmetrical property. According to symmetric property, we know that S11, S12 is equals to 0. So you can observe this here, how we are writing. You already understood S13 is equals to S23, S14 is equals to minus S24 for E plane T, and S34 is equals to S43 is equals to 0. Just we discuss it now in the picture. Next, according to the symmetric property, you can write like this: S12 is equals to S21. Okay, 1 is the input, 2 is the output. 2 is the input, 1 is the output. Similarly, for all this. For port 3 and port 4, perfectly matched. So we can write as S33 is equals to 0, S44 is equals to 0. If you substitute all these values, okay, what we have discussed now, substitute all these values in this matrix, we get this type of matrix. Okay, S21 we can write as 1 2 according to symmetric property. Okay, yes, this is S24, right? S24 is equals to minus S14. Okay, according to here, S24, okay, S24 is equals to minus S14. We can write like this. So after substituting all these S matrix, we have to go for unitary property. According to unitary property, you can write like this: S into S conjugation is equals to identity matrix. Substitute this, which is equal to identity matrix. Identity matrix is nothing but 1 triple 0 0 1 double 0 0 0 1 0 0 0 0 1. That is, the diagonal must and should be all 1. Remaining part is 0. It is the identical property. Okay, identity matrix. Sorry. Now go for a matrix multiplication, row 1 column 1, okay, which is equals to 1, and next row 2 column 2, which is equals to 1, row 3 column 1, sorry, column 3 equal to 1. Like this we get 4 equations, and simplify this. Okay, S11 into S conjugation we can write as modulus of S11 whole square, like this: S12 whole square, S13 whole square plus S14 whole square is equals to 1. From 1, 2, 3 and 4 equations we get, and simplify it, we get from third equation we get S13 is equals to 1 by root 2, and from fourth equation we can write as S14 is equals to 1 by root 2. Substitute these values in equation 1 and in equation 2 and simplify that. Okay, if you simplify it, and we get all values, S11, S12 and all the values. Okay, then write all the values: S11 is equals to 0, S12 is equals to 0, S13 is equals to 1 by root 2, like this. Okay, substitute all these values in this matrix. We get these values. You have to practice it. Okay, you have to practice it. I already posted this material to you, so you have to go through this. Okay, you have to simplify it, because it is the online class and everything is using of onboard, open board is somewhat difficult to write and everything. Just to go through this. After getting S is equals to this matrix, what we have to do means, okay, after completing the unitary property, we have to substitute in this: B is equals to S. S is the scattering matrix, what we get now, and A is the inputs. How many inputs we have? We have 4 ports, so A1, A2, A3, A4. and we can take our outputs at B1, B2, B3, B4. Okay, 4 ports. So for that, S into A. Okay, then we get B1, B2, B3, B4. What are the outputs means? B1 at port 1 we get B1, at port 2 we get B2 output, and port 3 at B3 output, B4 at fourth port output. Okay, and then after then we have to check it. Okay, like this, B is equals to S into A. B is the outputs, A are the inputs, S is the scattering matrix, that is a reflection, like this. Okay, and multiply this matrix, okay, 4 into 4 matrix, okay, into that A1, A2, A3, A4. We get remaining equations 3, 4, 5, 6. Okay, this is the output at port 1, port 2, port 3 and port 4. Next we have to check cases. Okay, what are the cases we have means? A3 is not equals to 0. Okay, here what are the cases we have to check means? We have different cases. Okay, here we have 4 ports. So far that we can check 4 and above 5 and 6 different cases. We have to check all the cases. Here, first of all, take port 3 as input. Port 3 as input. And take remaining all outputs. Okay, remaining all outputs. Okay, so A3 is not equals to 0. Okay, port 3 is not equals to 0. That means we are giving inputs. And what about the remaining? A1, A2, A3, A4 is equals to 0. A4 is equals to 0. Check this case. This is the case 1. And case 2, what we will do? Okay, take A1, A2 are inputs. Okay, that we are giving same energy as A. Okay, A1, A2 are inputs, and remaining A3 and A4 are outputs. So it is equals to 0. Check this case. A3 is equals to A4 is equals to 0. Check this case. And we have case 3. Okay, first of all, check these two cases and we will go for next case. Okay, A3 is equals to, not equals to 0, and A1, A2, A4 is equals to 0. So, oh sorry, in the diagram I just small mistake. It is not A3. Okay, A1, A2 is equals to A4 is equals to 0, equals to, okay, A4 equals to 0. Okay, this is the thing. Substitute these values in B1, B2, B3, B4. We get B1 is equals to 1 by root A3, B2 is equals to 1 by root A3, B3 and B4 is equals to 0. Is it right? Yes, correct. Okay, what is the thing? B3 0, B4 0. We get only output at B1 and B2. We already checked this, right? Okay, according to this, if you give energy at port 3, we get energy at port 1 and port 2, both are same. Okay, so B1 and B2 is same. B3 is 0. We are not getting output at port 3. Okay, we are not getting any reflection. Port 4 is also 0. Okay, B4 is equals to 0. B3 is also 0. We are getting 1 by root 2 energy, 1 by root 2 into A and 1 by root 2 into A. Okay, this is the same thing. So we are getting the same energy here. Okay, just go through this. B1 and B2 is equal. There is no change. There is no phase shift. Okay, so 1 by root 2 and 1 by root 2 is the same. Okay, A3 is whatever the input we are giving, the same energy it is we are getting at port 1 and port 2, but it is equally divided. And port 3, port 4 is 0. That is H plane T. This condition for H plane T. Okay, it is the thing. And next condition is A4 is not equals to 0. That means we are giving the input at a fourth port. Okay, we are taking input as a fourth port, and A1, A2, A3 is 0. That is, we are taking output at these 3 ports. Okay, that is E plane T. Okay, what we are getting, B1 is equals to 1 by root 2 into A. Okay, substitute these values in B1, B2, B3, B4, we get these values ma. B1 is equals to 1 by root 2 into A4, B2 is equals to minus 1 by root 2 A4, B3 is 0, B4 0. That means if we go into the diagram, here we are taking fourth port as input. Okay, and we are getting this is the output. Okay, B1, okay, this is the port 1, output is B1. B1 is equals to 1 by root 2 into A4. Here minus 1 by root 2 into A4 because 180 degrees phase shift, right? And port 3 we get 0. We already discussed about this. Okay, so the same values we can observe here. B1 and B2 is out of phase, minus 1 by root 2, 1 by root 2. Okay, B3 0, B4 0. And next take A1 is not equals to 0, A2, A3, A4 is equals to 0. That is, we are giving input at A1. Okay, first port. If you take a first port as input, then we can observe that at first port we get 0 output, and at B2, okay, B2 is also 0, B3 and 1 by root 2 into A1, and B4 is also minus 1 by root 2 into A1. This is the thing. When power is given to the port 1, nothing comes out of port 2, even though they are collinear ports. Okay, even though they are collinear ports, hence the port 1 and port 2 are isolated. Okay, isolated port. Similarly, if I give an input at port 2, it cannot come output at port 1. Okay, E and H ports are isolated ports. Okay, E and H ports are isolated ports. This is the thing. This point we have not discussed. Okay, if you give one input at port 1, we can observe, okay, the energy at E and H equally. Okay, similarly, if you take a particular energy, okay, if you give port 2, okay, as input, and port 3 and port 4 we get the output. Okay, we cannot observe any output at port 1. Okay, in the just a few minutes back we discussed in different way. Okay, that is, if you are giving both ports at port 1 and port 2, okay, if you are taking port 1 and port 2 as inputs, what are the outputs we get? 3 and 4. We discussed that. Okay, actually if you take only one port as input, there is no output at port 1. You can observe output at port 3 and port 4. Okay, this is the thing. And next case, A3, A4, A3 is equals to A4, and A1, A2 is 0. Okay, A3, A4 is 0. Okay, A1, A2, if you are taking A1 and A2 is equals to 0, that is A1, A2 are output ports. Okay, A1, A2 are output ports. At that time we get A3 is equal to A4. Okay, A3 is equals to A4. At that time we get, there is nothing but additive property. Okay, the equal inputs at port 3 and port 4 results in an output at port 1 only in phase and equal amplitude. Okay, it is the thing we can observe. And for fifth case, A1 is equals to A2 and A3 is equals to A4 is equals to 0. That is, we are taking A1 and A2 as inputs and A3, A4 as outputs. At that time we get only port 3. Equal inputs at port 1 and port 2 result in an output at port 3. This is the thing, ma. And when you go for applications, we can use a magic T. Okay, measurement of impedance. For example, if you want to find unknown impedance, you can arrange like this. Okay, Z1 at port 1, Z2 unknown impedance at port 2, connect known impedance, standard variable impedance at port 1, and unknown impedance what we have to find at port 2, and null detector at port 3, and microwave source at microwave sources port 3 and null detector at port 4. Okay, what happens means, here we are propagating some energy microwave signal, that is, we are giving the input here. Okay, if you are giving the input here, then the same energy will be transferred here and here equally, that is A3, 1 by root 2 into A3, 1 by root 2 into A3. According to this, we already know that B1 and B2. Okay, due to the reflection, due to the termination, this is the match termination rule. So due to the reflection, that is reflection coefficient rho 1, 1 by root 2 into A3 into rho 1. Here the reflected energy is 1 by root 2 into A3 root 2. Okay, we can observe at port 4, that is out of phase. So 1 by root 2 into 1 by root 2 into A3 into rho 2. Here 1 by root 2 into of this energy, 1 by root 2 into A3 into rho 1. So if the match termination both are equal, Z1 is equals to Z2, at that time at port 4 we can detect 0. That means the impedance of Z1 and Z2 is in equilibrium position. If it is vary, we cannot detect null detector, it will show some value. Okay, when the Z1 value and as well as Z2 value is equal, okay, Z1 and Z2 value equal, at that time we get null detection. Why it means? Because here it is same phase, here it is 180 degrees phase shift, so out of phase. So due to this combination of these signals, we get 0 output. Okay, when the impedance is different, Z1 and Z2, we cannot detect null detection here. Okay, based upon this we can find Z2 unknown value. Okay, by varying this. Okay, first of all, at one point, okay, I am transmitting some energy, microwave energy here. Due to this, null detector is not showing null, that is not showing 0, it's showing some value. Okay, it's showing some value 1 or something. Okay, at the time what I am doing means I am just varying this impedance value. Okay, at particular value only the null detector shows 0. At that time we can say Z1 is equals to Z2. This is the application. This is the application, just to go through it. This is the thing, you know how it works. Okay, next, magic T as a duplexer. Okay, magic T as a duplexer. We can use a magic T as a duplexer. How it means? At port 1 we will use take another slide here. Just okay, I will use this diagram. Okay, I will use this diagram. Okay, this is the port 1. Okay, now at port 4 we are connecting an antenna. We are connecting antenna at port 1 and port 2. Okay, port 2 is a transmitter. We are connecting a transmitter according to the diagram. Transmitter here, microwave source. Okay, transmitter and receiver are connecting at port 1 and port 2. Okay, transmitter and receiver are connected to port 1 and port 2 respectively. Actually diagram is somewhat different. Actually it is the receiver, right? Okay, a small change. It is the receiver. Port 1 is transmitter, that is microwave source. Okay, microwave source is there, and port 3 is perfectly matched, that is matched termination. Okay, here duplexer means the antenna must and should transmit and as well as receive continuously without any delay. So whatever the energy is transmitting, the signal must and should arrive at port 4 and as well as port 3. But here, due to the match termination, the energy is not reflected. So the energy will be directly transferred to the antenna. Okay, the same antenna receives the energy, okay, here, from here, and it will arrive at port 2 only, but it is out of phase. Due to this out of phase, the combination, okay, the standing waves is 0 at this R. Okay, so the signal directly received at port 2. So the transmitted signal and received signal does not combine at this point, because at port 2 is 180 degrees phase shift. So we can use this as a duplexer, Magic Tee as a duplexer. This is the application. The same energy does not arrive at port 3 ma. This is the thing. So this is the application of duplexer. Okay, just to go through these notes. Okay, this is the explanation about Magic Tee as a duplexer, just to go through this. Okay, next, Magic Tee as a mixer. Magic Tee as a mixer. Okay, the same diagram we will see about Magic Tee as a mixer. Okay, here we are using mixer. We are connecting at port 1, we are connecting mixer. At port 3 we are connecting a local oscillator. Local oscillator. Port 2 is perfectly matched, and at port 4 we are using antenna. We are connecting antenna. Here what happens means, whatever the signal we are getting at port 4, the antenna receiver, okay, antenna receiver receives the signal, okay, port 4, it can be arrived at port 1, and the local oscillator signal is also arrived at port 1. Okay, so due to the match termination, the energy is 0 here. The half power will be transferred to the port 1, and here also the half power will be transferred to the mixer. So the combination of these signals will be arrived at a mixer. Okay, so this is the thing. Okay, this is the application. So we can use as Magic Tee as mixer. Okay, due to the match termination, the signal is 0 at second port. Here also the signal will be equally divided for port 1 and port 2, but here due to the match termination it is 0. So the combination of F input, the frequency signal input, that is received antenna due to the received antenna, and local oscillator frequency, both are directly fed to the mixer block. So we can use a Magic Tee for mixer operation. Okay, this is the explanation about this. We get addition of 2 signals at port 1. Next, about rat race condition. Rat race junction, or we can also call it as hybrid ring. We will see how it constructed. Okay, we can also use, instead of using Magic Tee, we can also use a rat race. Rat race junction or hybrid ring. Here we can observe four ports. Port 1, port 2, port 3 and port 4. It is constructed in such a fashion that the spacing between the port 1, port 2, port 3, port 4 is also somewhat different. Okay, 1, 2, 3, 4. Okay, the spacing between this from here to here and here to here, the spacing is also different. Okay, if you observe here, what is the spacing means? Lambda g by 4, lambda g by 4. Only from here to here it is 3 lambda g by 4. Lambda g is nothing but the guided wavelength. Okay, if you take this center point, we have to take this center point, right? We have to take spacing from center of this waveguide. Okay, what is the distance from here to here is lambda g by 4. Lambda g is the guided wavelength. Okay, from here to here it is lambda g by 4. Here also lambda g by 4, and from here to here also lambda g by 4. It is constructed in this fashion, and only thing is from here to is 3 lambda g by 4, the distance. Okay, the spacing from here to here is 3 lambda g by 4. Okay, it is the thing. This is the construction. When you go for working, port 1, 2, 3 and 4 working, whatever the signal we are giving at input port 1, okay, the energy will be, okay, equally divided, okay, from here to here. Okay, whatever the energy we are giving, it is equally divided from here to here. And one thing, the energy will be rotated in anti-clockwise in the top, that is 3 lambda g by 4. And here at the bottom side, it will be in clockwise direction, that is in clockwise direction. From here to here we get the output. Okay, and again the same energy will be traveled here, and we get the output here. Okay, due to this, here also we get the same output, that is whatever the output we can observe at port 2. Okay, whatever the output observed at port 2, the same output we get at port 4. Okay, at port 3 the energy is 0 because it is clockwise rotation, it is anti-clockwise rotation. So due to this, port 4 the output is 0. Okay, at port 3 output is 0. This is the working. Okay, if you give port 2, okay, port 2 as input, it will work similarly. Okay, this is the thing. Okay, this is the working principle of rat race and hybrid ring. We can use multiple applications for this. Okay, it is also 4 port, so we can write as 4 into 4 matrix, scattering matrix, and S33 and S44 is a perfectly matched termination. Okay, port 3 and port 4, similar to the magic T. Okay, similar to the magic T. Here also the same thing. S11 and S2 is also perfectly matched here. So S11 and S2T is also 0. Okay. Okay. Similarly, S13 and S31 is also perfectly matched. S24 and S43 is 0. That is, whatever the energy we are giving here, in the diagram. Okay, whatever the energy we are here giving from energy at input 1, okay, input 1, output is 3, okay, the energy is 0 at port 3, right? Okay, so S13 is equals to S31 is equals to 0. Okay, here we are giving the input, but at output 3 is 0, so we can write like this. And similarly, if you take input as 2, S2, okay, and if you take output at 4, and as well as if you take S4 and 2, it is also 0. Okay, here the same thing, S24 and 42 is 0. How it means, for example, if you take I will draw clearly for your understanding purpose. Okay, for example, if you take 3, 4, if you fed energy at port 2, what happens means the same energy will be arrived here in anti-clockwise direction rotation, and remaining for ports it is clockwise direct rotation. Here, whatever the energy arrived at port 1, the same energy we can observe at port 3, but at port 4 it is anti-clockwise rotation, it is a clockwise rotation. Due to that, the both signals get cancelled. At port 4 the signals is 0. If you take port 2 as the input, okay, the energy will be equally divided in two parts, and in this direction the signals will be rotated in clockwise direction, and here it is anti-clockwise rotation, and the same output we can observe at port 1 and port 3, and the fourth port the both signals, clockwise rotation and anti-clockwise rotation signals, will be get cancelled. The fourth port is 0, so we can write that S24 is equals to S42 is equals to 0. This is the thing. Okay, ma? So with that we can substitute all the values and we get the scattering matrix. Okay, just to go through this, and up to here we discussed about the magic Tee and applications of magic Tee, and as well as hybrid ring. In the next class we will discuss about the directional couplers. Thank you very much, and you have to practice all this. Without practicing you cannot get anything, ma. Okay, just to go through that materials and everything.